Cool. Let me start the presentation. Yes. Yes, so I'm Jeffrey. I've been working on this collection of specifications for a little over a year now, and wanted to go through kind of why we're doing it and what it currently looks like, and then get any questions from you. So we'll talk about kind of, why we're doing it and what it looks like. So we'd like to improve how websites are distributed. To start with, I want to define some terms. We've got authors who write content. We've got publishers who serve the website that the content first appeared on. So a lot of times those are the same thing, but if you have like a journalist write an article and then the New York Times serve it, then that would kind of show the publisher being a different entity. And then you can have a distributor who actually serves the content to individual people or particular clients. Today, the distributor and the publisher have to be the same person or same entity, thanks to how TLS works. To some extent, you have CDNs in the middle, but the CDN has kind of full control over what the publisher says. So they can like forge content from the publisher, which you don't want in a really distributed model. So we can think of the distributor and publisher as the same thing today. And web packaging is trying to split that up. So to think of some of the problems that it causes when only the publisher can distribute their content. Imagine that you want to share an article that you liked with one of your friends. Right now, you click a share link in your browser. It goes to a messaging app, and you effectively share the URL, maybe with an image derived from it. It would be nice if you could share the actual page. So you'd like to be able to kind of copy the web page locally, send it directly rather than making them re-download it. And that's, if you heard the kind of elevator pitch just earlier, that's the, you have a friend that's offline or has very expensive data, and they can also get what you sent them even if they can't fetch it themselves. Another use case or kind of class of use cases is if you want to include some other content in your web page. So right now, if you think about how Twitter handles links, they'd like to embed the target of the link, but all they can really do is copy an image from it, copy some text, and then when you click on the link, you just open the other page. There's no good transition. It tends to be slow. And so like Twitter, when you click on the link, has a choice between either prefetching the actual article, the target article, in which case they've leaked the fact that you saw it, even if you don't click, or when you click it, you have to start downloading it at the click, and that takes more time than is really necessary. The navigation also can't do any sort of transition. You just get a flash of white, and it loads the target web page. You don't get kind of fancy UI effects like expanding the thing you clicked on to cover the whole screen. And so the primary kind of use cases that we distill from that, from kind of all of this. So one is that packaging can provide a better MHTML-like or screenshot-like format. So if you see a web page that you'd like to share, right now you might take a screenshot, so you get an image, or you might save MHTML, in which case no JavaScript can run. We think that unsigned bundles can improve on that. You get the actual HTML, you get probably JavaScript execution, you can have multiple pages from the same origin, and you can share it directly. Let's see. If the source website signed their content, you can actually install a whole PWA. So it can include service workers and full JavaScript and storage access and everything, because that signature gives you proof that it came from the original origin. And finally, the privacy-preserving prefetch that I mentioned, will allow like Twitter or like Reddit, or will improve the way that AMP does this, and allow websites to actually embed other websites without telling the source website that they're embedded until the user grants consent by clicking on it. And that improves speed. And with another technology that I'm not talking about today called portals, will actually allow a navigation that looks pretty and doesn't just kind of reload the page. So how does this all work? There's two layers, as I mentioned. You can sign a single exchange, so an HTTP request response pair. And the way that works is A.com will sign their content, B.com copies it, and then serves it to the user. And the user's browser shows A.com in the URL bar. At the lower level, that is accomplished by a new HTTP header called signature, which provides a list of exchange signatures. They include a URL for a certificate chain. It's a URL so that you can reuse the same chain for multiple signed exchanges and not transfer it multiple times. You get a timestamp range that the signature is valid. We are constraining that for HTTPS trust to less than 7 days to protect against vulnerabilities in the source site. So if an attacker finds a vulnerability that the site has fixed, they only get to use it for a pretty limited amount of time. There's a way to update the signature. So if the content doesn't change, but you need to extend that expiration date, there's a way to download a new signature without downloading all of the content. The signature covers the HTTP headers, and then one of those headers guards the payload itself, and that allows the website or the browser to load the exchange incrementally as it downloads. And then the header includes the actual signature of the kind of all of that. We're defining 3 ways to transfer one of these signed exchanges, although so far we're only really implementing one of them in the browser. So we're defining a content type called application signed exchange, which is just a file that holds the request headers and response headers and the signature. We expect to allow you to just send a normal response with a signature header, so that which allows this to work for things like SRI, sub-resource integrity. And then we're thinking about allowing you to use HTTP2 push to transfer this, but we're not sure that's actually going to be useful. And so that's probably the third thing that we'll implement if people actually need it. Also, feel free to interrupt me with questions if you have any. So you will need to get a new certificate in order to sign exchanges. For security reasons, we don't want to use the same certificate to terminate TLS connections as we use to sign exchanges, because a lot of the security properties are different. And so there's a certificate extension that has to be present in the certificate when you use it to sign exchanges that can't be present when you have a TLS server. So I wanted to focus on 2 particular aspects of the structure of signed exchanges that will wind up being useful later. So this is a list of signatures rather than just one signature. And that happens to provide cryptographic agility. If an old browser only supports one kind of signatures and a new browser has replaced those with a new kind of signature, the signature header can include both, and each browser will use the one that's valid for it. And second, we use X509 certificates because that's how the web's trust system works. But X509 certificates are really flexible, and you can also include signatures from certificates that are not trusted for a particular web origin. And I'll again come back to that, the extra uses for that later. Okay, the second layer of the whole system is bundles. So this is a zip-like format that maps requests to responses. We're not totally sure that requests are the right abstraction there, so it might map something else to responses. We're still working that out, and would love to get some feedback on kind of what actually makes sense. A bundle can have both signed and unsigned exchanges, and it doesn't have to be all one origin. You can mix and match. And we're also going to add the ability to sign a collection of exchanges together with a bundle. So a bundle can hold just a bunch of individually signed exchanges, but you can also cover a bunch with one signature, and that's faster and also provides some extra security guarantees that you didn't mix, that the attacker didn't mix up the versions of those signed resources. So now that you know the structure that came out of the original use cases, here are a couple more ways that we think we can take advantage of the capability. So you're probably all aware of things like Webpack and Parcel.js that that bundle up a collection of JavaScript and CSS and HTML so that you can serve it all at once rather than having to serve a whole bunch of individual files. We think that exposing the structure of those bundles to browsers will help speed things up and improve how they work. But we haven't fully worked that out yet. So we're kind of, this is something we think will be useful and that we're going to prototype, but we're not certain that it's going to be a good idea. Who here has heard of certificate transparency? Nobody. Okay. So um, so when your browser, or when at least Chrome, and I think the other browsers are also doing this, decides whether or not to trust a TLS certificate, it checks that that certificate has been publicly logged somewhere. And that prevents attackers from getting a certificate authority to misissue a certificate for them, and then they can man in the middle kind of individuals without anyone knowing that they've got a bad certificate. Once it's in the public log, the owner of the domain can see that it's been issued and can get it revoked pretty quickly. Binary transparency deals with the worry that a package author might give just you a backdoored package and then give security researchers the benign version, and you would never know because anyone who has the expertise to look for backdoors can't see the one that you got. And so with binary transparency, the packager would have to give that backdoored version to a public log, and the researchers would see that, oh, there's this weird version out there that we didn't know about and that we're not being able to fetch, and then they could find it. It's not obvious that that's the right model, but web packaging allows people to experiment with that. So I mentioned that you can have a list of signatures and certificates that are not trusted as web origins. The way this would work is the transparency log would have its own certificate that browsers recognize as being from a binary transparency log, and then they would check for that having signed your package in addition to the origin having signed it. Another use for the same kind of non-web certificate is for security audits. So like Apple's App Store is pretty famous for having restrictive security audits, and checking really well for malicious applications. We'd like people on the web to be able to get the same benefits. So if you as a user want to only run applications that have been checked by some particular security auditor that you trust, you should be able to configure that in your browser and at least get some notification of which applications have been endorsed by what entities. Enterprises can also use this. There's a lot of enterprises that only want or that trust particular origins more than just some random place on the web, and so they could configure enterprise policy to check that those origins have been signed by the enterprise's security team. Another use case is for censorship evasion. So if your censor is blocking A.com can just sign their content and hand it to B.com that is not currently being censored, and you can get it from there. Or you can pass things around on USB drives or whatever. So one example of this was in Cuba. There's a thing called El Paquete Semanal, which was a weekly dump of the internet passed around on DVD and used to get around the fact that the internet is mostly blocked in that country. And the way that it was done, people got no evidence that the content was actually real, that someone hadn't modified it on the way to them. With web packaging, they will get some sort of guarantee. Okay, so looking at the specifications, we've got kind of two relatively stable specs and then one that I'm currently writing. So signed exchanges and bundled exchanges are Ietf drafts. So they're in the first stage of becoming RFCs. The loading specification talks about how web browsers will actually load both of those. And the slides have a link to that, but it's pretty immature so far. Let's see, we've got a couple implementations so far. So we did a demo at Google I/O, and the way that we're managing the kind of various implementations is we've got an Ietf draft that we kind of release every time there's a checkpoint. So the 0.0 draft is what we implemented across Pinterest and the Food Network, producing packages, Google Search indexing them and serving them, and Chrome 67 loading them and showing the signed URL. In Chrome 69, we've implemented the 0.1 draft, and it's a little more secure. It checks for the certificate extension and for various aspects of trust in the certificates. And if you have Chrome 69, you can enable these flags and test it out. So you have to enable signed HTTP exchange. If you want to use your normal TLS certificate, then you enable the allow search without extension flag, and it will check for the extension. Now, when you're signing these exchanges, DigiCert is currently implementing support to sign the certificate extension. There's a Go program that you can use to sign exchanges, and Cloudflare is working on a prototype that will, like, if you're using them as your CDN, will sign whatever you want in their edge nodes. One thing I forgot to put on this slide is that the signing key has to be ECDSA on the SecP 256 curve. We picked kind of just one signature mechanism to keep things simple, and because RSA has a whole bunch of problems. So a lot of the certificates you're probably currently using are RSA, and you'll need to make sure to make a P256 certificate instead. We're planning to run an origin trial in the fall. Raise your hands if you know what an origin trial is. So Chrome is doing this thing to test out new specifications where we allow particular origins to sign up, and then we will enable the new feature on that origin, but not on origins that have not signed up. And that makes sure that we have contact information for when the specification changes. So we'd like to be able to kind of get feedback from web developers before the specification gets set in stone. And this gives us a better chance of doing that. we're thinking about compatibility plans. So we want to kind of figure out how long we want to support old draft versions, which means how long do we give web developers to upgrade their tooling to sign in a new format as the spec changes. And can we, we're probably going to change the specification so that if you are using a version that's either way out of date or newer than the browser supports, it can automatically redirect you to a particular, to a place that works. We're hoping to ship this by default in Chrome sometime next summer. We don't expect the full standardization process to be done by then, which is why that compatibility plan is so important. So we'll ship some version that we're pretty comfortable with, and then as the standards kind of work through the other, getting consensus from all the browsers, we'll gradually make publishers upgrade to the actual standard version. The kind of the last or the biggest case I know of this happening is the web component specs, where Chrome shipped v0, and then a couple years later, the other browsers changed everything and standardized on v1, and we're finally in the process of deprecating and removing v0. So we'll do something similar with web packaging. We'd like everyone to participate. So I've got a couple links. There's a GitHub repository. Who knows what the YCG is? So it's a way to do kind of fledgling specifications at the W3C, and things graduate from there as browsers kind of agree that they're a good idea. So right now we're a YCG specification. There's also a mailing list, which is currently fairly low traffic, but where I'll announce kind of new versions of the draft, and the origin trial and this workshop that we're hoping to hold in January. So there's concerns from Mozilla and from a couple other people that web packaging might serve to centralize the web. We think that it will help to decentralize the web. And so we want to hear from kind of publishers with opinions and kind of asking whether they're worried and what they're worried about and what we could change to increase the chance that this helps decentralize things and sort of take things out of the huge like Google, Facebook, like centralized control systems. And if, yeah, totally. Right. Yeah, so one thing that this is useful for, which I actually failed to talk about in this presentation, is it fixes AMP's problem. So Google AMP was a way for publishers to generate a format that Google could reserve on its own servers and prefetch in a privacy-preserving way, and let you click on links and instantly see the results. And so it's nice for users in that it's fast and it's privacy preserving, but it's also bad because you get the wrong URL at the end. You get a URL on Google's servers and not the actual publisher's servers. And it also, because of the privilege, like the way that it's shown in Google search results, is nicer than non-AMP results. And so that was kind of an unfair advantage for this web components format that other web components formats didn't have. So people really dislike Google AMP. Web packaging fixes one piece of that problem. They can now get the right URL. It doesn't fix all of the other problems. And we're working on some other systems, including portals that I mentioned and new feature policies, which will let non-AMP content get the same search results treatment. But when we're talking about kind of just the web packaging spec, there's a worry that it will make it easier for Google to, because it removes one of the problems with AMP, it makes it easier for Google to push this special format on everyone. It also, because it allows anyone to redistribute content that was signed, maybe the entities that kind of have the best serving systems will be able to distribute things best. And so we'll have some control over what they decide to distribute that way. It might give us a better lever to influence the web. And just full disclosure, I work at Google, so like there's no, I don't think there's any actual desire to do that. But sometimes, just because of our perspective, some of the things we design happen to be skewed that way. And so we want lots of input from other groups to make sure that they're not. Did that make sense? Yeah, and so we're having a workshop to make sure that we gather the feedback we need to prevent us from kind of accidentally skewing things. Okay, that's the whole presentation. What questions do you all have? So there's a couple ways to get the bundle in the first place. Ideally, you're browsing a website, you're just making normal requests for HTML pages. And then when the user says, oh, I actually want to save this as a signed bundle, there should be a cheap way to do that. And that's one thing that the signature header is for, because it can be served alongside the normal response. And it adds about 300 bytes. But then the browser can build up a bundle out of that, and get and include all of the signatures. It's also possible that we'll define a link tag that says, for this application, go get its signed bundle over here. And then you'll re-download the whole thing, but at least you'll be able to find it. Yeah, so you download the bundle by pointing to a bundle URL, but then its actual content has non-bundle URLs. Yeah. Yeah, when we're thinking about a Webpack output format, we'd wind up doing unsigned exchanges in the bundle. And then, so Yoav Weiss has kind of sketched as a design for this. You probably have a link rel equals bundle with some sort of digest that says, kind of fetch this bundle in order to get all of the resources covered by this digest. Okay. So the two big things. One is if you're thinking about emerging markets, which are, for this, markets with very expensive data connections. Anytime, so right now these markets have an existing ecosystem of peer-to-peer sharing of videos and Android apps. They're existing like Android apps that allow you to share files peer-to-peer. And if you're building a website that is useful for people in emerging markets, you should be thinking about how to sign your application so that someone can download it and then send it as a file to their friend. The second big application is sites like Reddit, Slashdot, clearly like Google, Facebook, Twitter, anyone who shows a list of links to other sites and can have some idea that a user is likely to click on one of those links. Um, if you um, if you can serve them a link rel prefetch for a bundle for the target of that link, then you can allow that link to load a lot faster without telling the target site, without kind of losing the user's privacy. So if you can already today send a prefetch link to the actual target site. But if you do that, you've then told the target site that your users saw a link to them, which the user may not want the target site to know unless they've clicked the link. And with web packaging, you can preserve the user's privacy and still prefetch those links. And that means that both the sites that serve the links and the targets of the links should be thinking about how to sign their content. Right. Okay, so this question was, what's the difference between signed and unsigned exchanges and bundles? So a signed exchange is an HTTP request response pair with a signature that proves that it came from the origin that it claimed. So the HTTP request will include a request URL, and the signature needs to be from something that's trusted for that request URL. There can also be other signatures that are trusted in other ways, but they're kind of less important for the primary use cases. An unsigned exchange is an HTTP request response pair without that signature. And then a bundle is a collection of those request response pairs. And a bundle can include both signed and unsigned exchanges. Bundle's kind of like a zip file of exchanges. Okay, so the question is, what's the kind of most frustrating obstacle that we hit on a day-to-day basis? Let's see. Sorry. Kind of. I mean, that's kind of a fundamental problem of pushing out a web standard that, like, we can't convince other browsers to implement it until publishers have implemented it, and there's no reason for publishers to do it before other browsers have implemented it. But I don't know that that's particularly frustrating, because that's just how standards work. Like, we have to bootstrap in some way. So to some extent, getting people to pay attention can be frustrating. So when when we first started working on this, before it became clear that AMP was going to be an important user, there was just no reason for, like, security reviewers to pay attention. They could just say, no, this is scary, don't do it, and stop thinking. And so getting actual reviews can be frustrating. And then as you get closer to being a real thing, actual reviews start showing up. And once we ship, I'm sure we'll get plenty of reviews telling us we did it wrong. Yeah. 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 So this is a question. Sorry. Yeah. So this is a question about kind of can CDNs take advantage of signed exchanges and bundles of signed exchanges to kind of fill your cache for cross-origin resources? And we would really like that to work. It's something that's really attractive. Akamai is really interested in doing it. Unfortunately, if you think about how to decide whether to serve the cross-origin content, we haven't figured out a way to make it work in a privacy-preserving way. So imagine that you're opening a website on foo.com and they use jQuery, and your CDN has a signed copy of jQuery that they could serve you, and it would fill your cache for the right for like jQuery.com/version. But it's only beneficial if they can serve that once, fill your cache, and then not serve it the second time. But there's no way for you to tell them that you already have it without revealing that you've been somewhere that uses it. And for jQuery, maybe that's not deadly. But for a less common resource, it gets like telling an arbitrary origin that you've been somewhere that served that resource is a terrible privacy leak. And it's hard for a browser to know which resources are going to be privacy leaks and which ones aren't. And it's hard for CDN to know that. Um, and so we don't have a way to make this work without kind of telling everyone on the internet where you've been, which we can't do. If you have any ideas about how to do this, let me know, because it would be amazing. Yes. Have any other browsers expressed interest? So Mozilla is publicly worried. Safari is fairly publicly worried. Um, Edge has promised to say something supportive in public, but hasn't said it yet. Um, so Edge and Bing have some of the same goals as Google Search, to be able to kind of serve these signed exchanges from the search results page. And so they think it looks attractive. And kind of we're working with them to figure out kind of what they're going to say and what feedback they're going to give publicly, kind of as they investigate and come up with feedback. Right. Yeah, and we hear the security teams at Mozilla and Safari being worried about it because it is actually scary from a security perspective. And then we hear some rumblings from the DevRel communities at the same places thinking this is a really neat new feature and we should look at it more closely. So yeah, none of these organizations are monoliths. Um, Mozilla is particularly bad at speaking with one voice. Um, so you hear kind of random stuff from Mozilla and don't know what the organization thinks. Um, and that'll work itself out as more people review it. I think Google has a similar problem that you hear from a bunch of different individuals, and it's hard to know what the organizational voice is. And then Edge and Safari have better systems for aggregating one opinion. So Yeah. So the question is, what if you had a privacy provider who could kind of intermediate some of the privacy sensitive bits? It's so that idea has come up in other contexts, but we haven't had a concrete idea of how to use it here. The case that it's come up is in WebAuthn, or that I've seen it come up recently is in WebAuthn, where some attestation bits might get offloaded to a privacy provider. It's often hard to identify who users trust to guard their privacy, because that organization winds up knowing not just what any one person would know if you didn't have a privacy provider, they know everything. And so they become a really attractive target, and users have to have a lot more trust in them than they would have to have in any particular entity if you didn't have that intermediate. And so it's plausible, but it's hard to do well, and we have to kind of figure out what that organization is before we can, like, we have to pick at least one example of that organization before we can start designing around its existence. We need an existence proof. Yeah, we're worried about how authoritative that repository is. It's not connected. It's not currently connected to the release process, as far as I know. Um, and so it's, even though it exists and we would like to use it, we're not totally sure how it works yet. And I think Chrome and Mozilla are currently talking about how to use that repository. Alex Russell has strong opinions about it. So talk to him if you want thoughts. It's it's called standards positions. I forget exactly. Yeah, no problem. Um, yeah. So if you have kind of informal questions that you just kind of want answered, um, I will probably see things on Twitter or kind of direct email best. If you have kind of questions you want to be public and that you think like that you're not embarrassed to ask, then the WPAC mailing list at the IETF, which is linked from the slides, is a good way to discuss things. And then if you see particular problems or new features or changes you want to make to the specifications, then GitHub is the right place. Yes, my slides will be linked from the meetup page and from the public video soon. Okay, thanks. Have, yep, no problem. Bye.